Today we're going to talk about determining domain and range from a graph. So the first thing we're going to do is look at some definitions. And the first definition is domain. When we're talking about domain, we're talking about the set of all x values. So if we were looking at the set of ordered pairs over here, where we have this -2, 8, 4, 0, and 5, 8, our domain would be -2, 4, and 5. Domain is just the x values, and in every ordered pair, the x is coming first. If we were talking about a graph on a coordinate plane, we're talking about the domain. Once again, we're talking about the x. So that's the horizontal axis. So with a graph, we want to look from left to right. Make sure you write that down, left to right, on the coordinate plane on the graph, because that's what we're really going to focus on. If we were talking about the range is the set of your y values. So once again, if we came back and looked at this set of ordered pairs, our range is going to be 8, 0, and then 8 again. So range is going to talk about the y's. So in a set of ordered pairs, y is always the second number. If we're looking at a coordinate plane at a graph, the y-axis is the vertical axis. So we're going to look from bottom to top. And like I said, make sure you write that down, because that's the part we're really going to focus on is the graph. So range is bottom to top. Domain is left to right. So now we're going to talk about the x-intercept. So the x-intercept is where a graph crosses the x-axis. So if we're talking about the x-axis, we're talking about the horizontal one, so the one that runs left to right. So if we're looking at this picture, then the x-intercept, notice there's a point where it crosses on the x right here at -3. So if we were going to write that as an ordered pair, it would be -3, 0. And then it crosses over on this side as well. So this one actually has 2 x-intercepts and 1, 0. So x-intercept is where it crosses the x-axis, which must mean that if you're talking about the y-intercept is where the graph crosses the y-axis, which is your vertical axis, your up and down. So if we look at where this graph is crossing the y, right up here at the top, so that's at 6, but since this is the y-intercept, we start with 0 and then where it crosses, which is 6. Okay, interval notation is a way of representing some interval as a pair of numbers. Okay, it's a way of representing an interval as a pair of numbers. There's a couple ways that you can show this. So one way is using soft brackets, which is what we have here, so which are like parentheses. You use this when a number is not included, when some number is not included. So if we had something like this inequality, x is greater than 8. So the way we showed that before on the number line was that we had an open circle on 8, and then we shaded in the direction of infinity. So if we were going to write this in interval notation, we would say that we're starting at 8, we would put this soft bracket because we don't have a closed circle on 8, and we're going all the way to infinity. If we were looking at hard brackets, which is what we have here, this would show that we're including it. This actually should be x is less than or equal to, there's a typo here, less than or equal to 8. So on our number line, we would be at 8 again, but this time we would have a closed circle to show that we're including 8. Less than 8 would go to the left though. So this time, if we're reading left to right, we're starting at negative infinity, and wherever you use infinity is always going to be a soft bracket, but we're going up to the number 8, and we're including 8, so we're going to put a hard bracket. So now we're going to look at some examples. If you flip over your note sheet, this is the very first problem on the back. So the directions ask you to determine the x and y intercepts from the graph and then determine the domain and the range. So down here at the bottom we actually have the domain listed first. So we're going to start with that. So if we're looking at the domain, remember we defined the domain as the set of all x values, and the x-axis is the horizontal axis. So when we look at this graph and we ask for the domain, we're saying how far left to right does this graph run? Well, if you look at the line, it has these arrows on it. So if you have arrows, that means it's going on forever, which is talking about infinity. So it's going to keep going left for forever. So it's going to start at negative infinity, and it's going to keep going right forever because it has the arrow on the right side as well, up to positive infinity. And when you're talking about infinity, you're always going to use soft brackets. Now, if we look at the range, if we go back to our definition of range, our definition for range was the y values. So y is looking at the bottom to the top. How far from the bottom to the top is this going to run? Well, once again, we have these arrows on it, which means it's going on forever. So that means, once again, we're going to go from negative infinity up to positive infinity. So now we're going to look at the x-intercept. So our x-intercept is once again where it crosses the x-axis, which we already marked here as our left to right axis. So if we're looking at the line on the left to right axis, which is the x, it crosses right here. So our x-intercept is always going to start with the number where it crosses, which looks like it's 3, and then it's always going to end with 0 because it's not going up and down. Whereas if we look at the y-intercept, where does it cross the y-axis, which is the vertical one, which is right here, our ordered pair is always going to start with 0 because you're not going left and right, but in this case, we're going up 1. So our y-intercept is 0, 1. Okay, now this is example 5 on the same side that we were working on example 1. So the directions here are the same. Determine the x and y intercepts, and then determine the domain and the range. So the first thing I have listed here is the domain. So I want to look at the domain first. So once again, the domain, you're talking about x values. So your x-axis is your left to right. Notice on this graph we don't have arrows at the end. We have these points. So that means we're not using infinity because there are no arrows. So from left to right. So the furthest left it goes out is this point, which it looks like is negative 1. And notice how the circle's filled in. So that means we're going to put a hard bracket at negative 1. Then we're going to say, well, how far out right does it go? Which is right here, which it looks like is 3. But notice on this side we have an open circle. So that means we have a soft bracket because that point's not included. Now when we look at the range, we said range is our y value. So we want to look from the bottom of the graph, which this looks like this is as far down as it goes. And that point is 1. And notice once again, that's a dark spot it's filled in. So we're going to have a bracket at 1. And how far up does this go? Well, this looks like this is the top spot of the graph, which is at 6. Once again, there's not an open circle, So that's a hard bracket. Okay, the next thing is the x-intercept. So where does it cross the x-axis, which is back down here on the left and right. And it does not appear to cross that. So there's not an x-intercept. So we'll just say none. And then the y-intercept is the last thing. So where does it cross this axis, the vertical axis, which is right down here. We had already marked it. So y-intercept's going to start with 0, and then the point where it crosses, which is 1.